Hello and a very warm welcome to the very first video of the Geokloud Consulting YouTube channel. My name is Kingsley and I'm thrilled you're here to join me on a journey into the fascinating world of spatial data. Now, have you ever used Google Maps to find the quickest route? Check the weather app to see if you need an umbrella, or even seen a news report that shows a map of election results? If you have, you've already interacted with the technology we're going to talk about today, GIS. So, what on earth actually is GIS? Looking at our course outline today, we'll be looking at the introductory session of a comprehensive training program on GIS. Throughout this session, we'll delve into essential topic to provide you with a solid foundation in GIS. We'll explore different topics and ride along together. So let's go through with the overview of GIS. As I said earlier, what is GIS? GIS stands for Geographic Information System, and at its core is a technology used to create, manage, analyze, and visualize all types of data that has geographic component. Think of it as a combination of map and a powerful database. While a regular map shows you where things are, a GIS actually shows you where, the what, and the why. So let's always remember that. GIS shows us the where, the what, and the why. It helps us see, understand, question, and interpret data to reveal relationship, patterns, and trends that we might otherwise miss. So looking at it, a GIS is not only a tool for making map, it is a system for data analysis. Let's have in mind that we have various components of GIS. A GIS is not just a single thing. It's a system made up of 5 key components that work together. The hardware, this is the computer you're actually working on, the server that stores the data, and any device used to collect it. We have the software, this is the program that provides a tool to work with the data. You might have heard of some like the ArcGIS, the QGIS, AOIS, EDAS, and many others that will go along with as our program goes. The data, this is the very heart of GIS. It is the geographic information we'll be exploring, and we'll dive deeper into it in just a moment. The people, that is us, the users, the analysts, the developers who operate the GIS to solve problems. Then we have finally the method. These are procedures and scientific principles we use to conduct our analysis and create our maps. Just a reminder, we have various types of data, but we'll be looking specifically at spatial data. Now, for the most exciting part, the data. In GIS, we work with spatial data, which represent features on the Earth's surface. This data primarily comes in 2 flavors, vector and raster. First, vector data. Vector data uses points, lines, and polygon to represent discrete, distinct features. A point could actually represent a single tree, a fire hydrant, or a customer's address, while a line could represent a road, a river, or utility pipeline. A polygon could represent an area like a park, boundary, a lake, or even a country's border. Then we have the raster data, as we can see on our screen. This is a raster that are made up of grids or pixels, just like our digital photograph we take with our phone every day. Each pixel is a grid that has a value. This is perfect for representing continuous data like satellite imageries, elevation map, or even temperature map. But still remember, as always, this is just an introduction, and definitely as we move on, we'll get to play along with most of this data we're talking about. Just like we understood the spatial data, what are the various procedures for inputting spatial data? So how can you actually get all this data into your system? There are actually several ways we can actually digitize it by tracing features from an image or a paper map. We could use a large format scanner, we could get out satellite imageries, we could enter in coordinates by GPS, conversion of existing database, and the list goes on and on. Let's just quickly look at a quick overview of our attribute table. So now there is where GIS becomes truly powerful. Every spatial feature, whether it's a point, a line, or polygon, can have information attached to it, and that's what we call the attribute table. So imagine we have a point representing a school, or a school, or let's say a government employment record. Just let's use what we have on the screen. So this attribute table gives us probably his location, his name, his occupation, and value representing the salary he'll be earning monthly. So each geospatial data comes with an attribute table, and basically attribute table are there to actually give us more information about where, what, and why for that very data. So as we move on, we'll look at brief introduction to GPS or remote sensing. We have mentioned this briefly, but they are crucial for data collection. GPS gives us highly accurate coordinate system. Let me make a point of that. Forgive me for not actually using what's on the screen, but it's more like a handout while I give us a more clear picture of what we have on the screen, allowing us to map the precise location of features in the world. When you're using a GPS, it gives us coordinates that gives us the longitude and latitude of any location you may be at that very point in time. Then remote sensing is the use of satellites or aircraft to capture information about the Earth's surface. But remote sensing, when we're talking about remote sensing, the science of actually obtaining information about any Earth's surface without actually being in contact with it. This is done, as I said, using satellite aircraft. Satellites have sensors in them, and it's our primary. It's majorly our primary source for a lot of raster data. So if most of our raster data we derive them through remote sensing, like the satellite imageries we use day to day. We have various applications. Okay, so we have all this technology and data. What do we actually do with it? The applications of GIS are endless, and almost every industry, for example, the urban planning management, environmental sciences, where GIS is used to track deforestation, monitor pollution, and model even impact of, climate change. Model impact of climate change over time in future predictions and all. Then we have the urban planning. Cities uses GIS basically to manage zoning, plan new transportation system for routes, for best location for placing of new hospitals or even new schools. We have businesses, it can be used business-wise. Retailers can use GIS for site selection to find the perfect spot for a new store, and logistics company could actually use GIS to plan the most efficient delivery routes. Also for emergency services, police can use GIS to identify crime hotspots, and firefighters may actually use it to manage responses during wildfire. Basically, if a question involves the world where, GIS can actually help us answer it. We've actually gone through very few basics. What does a GIS do? We've been able to understand it collects, store, organize, and distribute data. It's used for criteria matching, allows exploration of relationships among data layer, allows scenario testing, serves as a data handler for other analysts, aids visualization. It's cheap in terms of human resources, basically, because when you actually get more used to GIS, you tend not to even need various people. You can just sit behind your screen and run analysis that in the past takes months, takes years to actually get done. Just by you sitting behind your screen. Things to know: GIS is actually not easy to use. You actually have to understand. You actually have to dedicate time to learn. GIS is something that if you learn today and you actually get to stop learning, you actually get to. It's more like a car. It's more like a product that when you do not use it regularly, it gets to slip off from you. So that's why we are advised that you constantly daily train. If you're not watching daily, get at least a weekly plan. Sacrifice an hour or two weekly to learn something new, to practice something. It needs analytical capabilities, but to the very barest minimum, it's actually very easy to understand, and it's able to make decisions. So it's not able to make decisions rather, because that's your job. It's your job to impute the data. It's your job to actually tell you what to do, and in most cases it's not free from few words. So GIS is fundamentally a problem-solving science. Many applications of GIS across a wide range of areas, as we have been seeing, and that is just a quick introduction to the world of GIS From a simple map on your phone to probably complex global analysis, GIS is a powerful tool for understanding your world in a spatial context. Thank you for watching this very first video from Geokloud Consulting. I hope you found it helpful. If you have any question, please drop them in the comment section below and we will be there to answer you promptly. Don't forget to like this video if you learned something new, and be sure to subscribe and turn on the notification so you don't miss our future tutorials and deep dives into the world of geography. Thanks once again for joining me, and I'll see you in the next one. Thank you.